Mm-hmm.
Nicholas, thank you so much for that presentation. We do have some questions here from our audience. The first one asks, you mentioned the possibility to make armor with multiple functionalities. Can you give me some examples of functionalities that are possible to incorporate into armors made from LBL composites?
Oh, that's a very interesting question, and we are thinking about it for quite a long period of time already. The armor is heavy. The armor has to be on the soldier and on the vehicle all the time, and so we thought that it might be a good idea to include some other functionalities in it. One, LBL technology allows one to make not only high strength materials but also conductive materials. This lends itself for the possibility to make the armor which can detect the status of the troop. Basically, it will be a combination of the high strength and sensor functionalities. It can also be used for communication. We also are thinking how this armor can be used for the storage of energy, and this is also quite important a problem for many soldiers and for many vehicles, because you have to have the battery, and some of the armor, if it made conductive, if it made with a certain capabilities to store the charge, then it can also provide the functionality of the batteries as well.
Okay, another question came in and it asks, your team has a lot of success with transparent, ultra-strong materials and transparent armor. What are the next steps in this direction that you are planning to take?
That's a great question. We do have quite a lot of success in this part, and we're happy that the first examples of transparent armor that we have, they perform quite well. There are some engineering challenges for the development of the best performing transparent armor and optimization of its protective capabilities. We would like to identify the best application target, for instance, the threat. Should it be a 7.62 projectile, or maybe the 9mm, or actually even greater calibers of the projectiles? So once we identify these challenges or these technological targets and what is the most needed for the industry, for the protection, then we'll scale up the technology, and in collaboration with our business partners, we will transition into the pilot scale and later on in large scale production of the transparent armor.
Okay, we have another one that came in here that asks, how soon can we see the new armor or new materials?
That's also a very good question. We're doing our best to accelerate this process, and I think LBL technology has a lot of possibilities here. We're working on acceleration of the manufacturing, as well as on the identification of the best or of the optimized stack of the material that can give us the best transparency and the best mechanical properties. We think that all the problems that we face are very standard. They do not require any major technological advances, and given adequate funding, given the aggressive management team of the company, I think we'll be able to give advanced armor for, let's say, vehicles in a year and a half. And currently, we're working on, that's enough. Yeah, I mean, the next question.
Okay, the last question we have time for today asks, this work is a joint effort between a small company, Nico Technologies, and the University of Michigan. What are the benefits of such a partnership?
Oh, thank you for that question as well. In the future, I think the collaboration between the universities and small companies is the way how the research has to be carried out. It has multiple benefits for the technology because it tremendously simplifies and accelerates the transition of the latest achievements in the lab to the technological landscape of industry. Our business partner, Nico Technologies, are focused on the pilot scale production of the transparent armor and other ultra-strong materials by LBL. And they serve as the interface between the university and the big industry. It also has the benefits for the academic researchers and for the small business. For us, for the academic researchers, in many ways it opens our eyes to the real problem that industry faces, not the problems that we think it has. And also it provides quite a lot of fulfillment to the inventor when he or she sees the actual application, the actual product, the actual thing that protects the other people. Overall, I think the benefits for such collaboration needs to be expanded a lot more, and I think the agencies which funded this research need to be thanked again for the possibility to make it happen. And I think that's the way how the research needs to be done in the future, because it gives a tremendous boost for the academic research and for the technology in the same time.
Okay, Nicholas, thank you so much for being here with us today and for your informative presentation. We really enjoyed it.
Thank you very much. I'm glad to be here and back to you, Jim.